This is the second part of our lesson on section 5.5 for pre-calculus. Before I do that, I noticed that there were a couple of, a kind of problem that I did not cover, that I probably need to cover, that was supposed to be covered on A. So let me do a couple of them where we've got negative numbers. Let's look at 7A. Okay, this time we could have arctan of a negative number, and I think all of the examples I did before was just arc functions of positive numbers. So let's cover a negative number before we go on to the second part of this. We've got our two triangles again memorized. 1, square root of 2. These are right triangles. Pi fourths, and we also have the 1, 2, square root of 3 right triangle, where we've got pi sixths and then pi thirds. Arctan is 1. Now, I'm going to go ahead and take it as if it were just arctan of 1. And if I go arctan of 1, tan of what is 1? Well, we know that tan is opposite over adjacent. Therefore, arctan of 1, what angle do I have when opposite over adjacent gives me 1? Well, I see that that would be pi fourths. However, if I take tan of pi fourths, I get 1. I do not get negative 1. Now again, if we go look in our range to have negative 1, we know that they're going to tell us that we're on arctan, we're going to be between negative pi halves and pi halves. They got parentheses because we know that at negative pi halves and at pi halves, tan is actually undefined, but we get right up to it before it becomes undefined. So that tells me that my answer for this thing right here is going to be negative pi fourths, because when it's a negative number, I'm going to be going with tan. I'm going to be going because of the domain of arctan. I'm going to be, the range of arctan, I'm going to be down at negative pi fourths. Okay, let me work another one. Let's work 9A. Okay, first of all, arc cosine, we know that that's adjacent over hypotenuse. We're going to look and find adjacent over hypotenuse, what cosine of what angle adjacent over hypotenuse will give me 1/2. Cosine of pi thirds, the adjacent to pi thirds is 1, the hypotenuse is 2. I've got adjacent over hypotenuse, I've got 1 over 2, so I see that it's pi thirds. Now this is a negative number. Since it is a negative number, I go back and I look at my range on the cosine, arc cosine function, and when I see that arc cosine will be negative in the second quadrant. So I've got pi thirds in the second quadrant. In other words, they're telling me up here that I'm going to go from 0 to pi. So since I'm in the second quadrant, I want to know what pi thirds is in 2. Pi thirds in 2, if you remember, pi thirds in 2 is like this, is pi thirds. What would this have to be? Because we know that they add up to pi. So this would be 2 pi thirds. Remember, we're going to take pi minus pi thirds. That gives me 2 pi thirds. 2 pi thirds and pi thirds add up to pi. So I know that my answer in this case is 2 pi thirds, because I know that I'm between 0 and pi. And when it's negative, that put me in the second quadrant, and I have 2 pi thirds. Okay. Now then, let's go on to problems 23 through 47. And let's go ahead and pick, let's just start off with, let's start off with number 31. Let me go back. I'm sorry. Let's get into the second part of it. Let's just start off with the first one. Now you're really going to like problems 23 through 30 because all of them are going to be, well, if I take, and I'll show you why it's the case, but if I take sine of arc sine of 1/4, I'm going to get 1/4. Why? Well, again, problems 23 through 30, if they have an answer, it's just going to be what the number is right here. Now, some of them don't have an answer, but we'll talk about that in a second. I'll have this thing right here. Now, this is what it means. If I were to take arc sine, we know that we have arc sine being between negative pi halves and pi halves inclusive. That's between negative pi halves and pi halves inclusive, means we have the brackets. And we've got 1/4. Now, when it's positive, all the inverse functions of a positive number will be in the first quadrant. So I've got opposite, which is 1, over hypotenuse, which is 4. So I have this right triangle. Now, with the right triangle, I could use the Pythagorean theorem and I could get this side. But since we're talking about sine anyway, there's no need to. Sine is opposite over hypotenuse. So I see that the answer is 1/4. So again, let's talk about what we just did. I've got arc sine of 1/4. That means the angle that we're talking about, this angle right here, is going to be opposite over hypotenuse. So opposite in this case is 1, hypotenuse is 4. So I've got this right triangle that we're working with. Now then, they turn around and want me to find sine of this angle. Sine of this angle is 1/4. So it's just kind of like taking one step forward and one step back. We start off with 1/4. We take arc sine. We have this. We take sine of this, and we've got 1/4. Let me do another one. Let's do number 29. Okay. Now, according to what I just told you, we already know the answer is negative 1/5. Let's talk about why the answer is negative 1/5. Okay. First of all, when we're talking about arc cosine, we know that we're either in the first or the second quadrant. We're between 0 and pi inclusive, puts us in the first or second quadrant. It's negative, therefore we know that we're in the second quadrant, like so. And we know that cosine is adjacent over hypotenuse, so this would be a negative 1, and the hypotenuse would be 5. Now then, I'm going to take cosine of that angle, and here's the angle right here. Here's the reference angle right here. And I'm going to take cosine of this angle. Taking cosine, that is adjacent over hypotenuse. Negative of adjacent is negative 1, over hypotenuse is 5, and I got negative 1/5. Now, that's why it works. Easy way of doing it is, we know that when we take the function of the arc, of function of that same thing, of this number, that the answer is always going to be that number. There's why it works. Now they tried to throw a little curve at you, so let me go ahead and do one that's got a curve ball in it. Let's look at number 26. All right, now I really wish I had you guys in class right now, because this would be one, and I'd ask you, well, what's the answer to this thing and why? And I'd wait a while and let your minds wander a while and play with it, and then somebody would end up answering. Well, the answer is there is no answer. The answer is there is a null set. And I'd say, why? Well, when I take sine of anything, there's no way. We know that sine of an angle, we got opposite, we got adjacent, and we got hypotenuse. We always know that the hypotenuse is the longest side in any right triangle. If we know that, and we've got sine of 5, we're saying that opposite, this number divided by that number, is going to be greater than 1. Well, there's two ways we can do it. One of them just common sense. Can this side right here be longer than the hypotenuse? The answer is no. So we could not have 5. Also, we know that the range on the sine function the domain on the sine function, the domain on the sine function, if we went back and looked at our deal, we see that the domain on this thing is going to be from -1 to 1. We also have our sine function memorized, which did this thing. Of course, we know it goes forever in both directions. And there's no way that on this graph that we have an answer greater than 1 or smaller than -1. Therefore, there cannot exist arcsine of a number that is less than -1 or greater than 1. Okay, of course, you're just going to look at it and you're going to say, well, I know that I can't take an arc function of something less than 1 or greater than 1, and we take off and got our answer. All right, let's go on. I want you to look, and these are the ones that get a little more complicated. I want you to look at problem. Let me do an easy one, and then I'll come back and do one a little more difficult. Let's do 31. Okay. Now, I'm going to reason this thing on out a little bit. However, a lot of you are going to look at that thing and already know the answer is pi-4, and that's okay. Now, some of you can't just write this number this time. Now, this one and a few more, we're going to be okay. As long as we're in the first quadrant, I know the answer is going to be this, but they're not going to all be in the first quadrant. So, I've got sine of pi-4. If I have sine of pi-4, that's sine of a number in the first quadrant. Sine of pi-4 is, I've got 1 over the square root of 2. I'm going to leave it way, since I'm going to be taking arc sine of, I'm going to leave it as 1 over the square root of 2 for now. We know that we would not be allowed to leave that as an answer, because we'd have to change this to the square root of 2 over 2. We will not allow radical to be in the denominator. We will not allow radical to be in the denominator as long as we are in pre-calculus or college algebra. However, next fall, when we get into calculus and things get more complicated, we will be allowed to leave a radical in the denominator. But for now, no. For the final answer, we can work with it there, and we're going to work with it there. Sine of what is 1 over the square root of 2? Well, that's pi-4. And you say, well, that's just like the ones we had to start with. Yes, it is. It's the opposite, but it's still the same. I mean, we're going to get the same answer we started with as long as we are in the first quadrant. Okay, let's pick, I'm gonna pick another one in the first quadrant and work it, just to make sure we're all on the same page, and then I'll take off and do the ones that are a little more interesting. Let's do number 32. We'll do 39, that looks good. Okay, tan of pi fourths. Tan of pi fourths. Tan of pi fourths is opposite over adjacent. Tan is opposite over adjacent. So tan of pi fourths would be 1 over 1. So I've got arctan of 1. Arctan of what is 1? Arctan of pi fourths is 1. Again, as long as we're in the first quadrant with that angle there, this and the answer to problems like this are going to be the same thing as what we started with. Now, I want to go through the thought process of why that's true. There's why it's true. Because we're going to get to problems now, and I'm going to bring one up. We're going to get to problems like number 33. Okay, now, first of all, I'm going to take sine of 3 pi fourths. Now, this is just like problem we've done in the past. We know how to take sine of 3 pi fourths. We know that this is sine of pi fourths in quadrant 2. And when we did reference angle of 3 pi fourths is pi fourths in 2. And I made you, I know the book, when it does reference angles, it just says sine of pi fourths, doesn't put the quadrant it's in. In this class, I made you go ahead and put the quadrant that you're in. I want you to think of that instead of keeping it in your head. I'm going to make you actually write it down on paper. Sine of 3 pi fourths is sine of pi fourths in 2. Sine of pi fourths, well, sine of pi fourths is 1 over the square root of 2. Now, I'm going to leave it like that because we're going to be taking the arc sine of it. This gives me a positive, I'm taking arc sine of 3 pi fourths is 1 over the square root of 2. Question is, what is arc sine of 1 over the square root of 2? Now remember, we told you when we did this, that, and it's back if they gave it the first page we look back on. That's looking back on page 440, and it says on there that the range is going to be from negative pi halves to pi halves. The answer's got to be between negative pi halves and pi halves. Arc sine of what is 1 over the square root of 2? Sine of pi fourths is 1 over the square root of 2. So my answer is pi fourths, not 3 pi fourths. So this is the ones that change the thought process a little bit. These get a little more interesting. Let's do another. Let's do number 37. Arc cosine of 7 pi 6. First thing we're going to do is find cosine of 7 pi 6. We're going to plug it in here and then take arc cosine of it. Cosine of 7 pi 6. A little review. We're going to say that is cosine of pi sixth in quadrant 3. Now, we've done a lot of problems like this, guys. Cosine of 7 pi sixth is cosine of its reference angle, which is pi sixth in 3. All right? Cosine of pi sixth. Cosine of pi sixth, that's adjacent over hypotenuse. That's the square root of 3 over 2. And cosine in the third quadrant is, all students take calculus, and here we know that tan is reciprocal, cotan are positive, everything else is negative. So we've got negative square root of 3 over 2. Okay? That tells me that since I've got negative square root of 3 over 2, then we're talking about cosine of what is the square root of 3 over 2? That's pi sixth. But since it's negative, we know that we've got to write the thing. If I go back and look on page, if I look back on page 441, bottom of the page tells me I'm between 0 and pi. So it's negative, and so it's between 0 and pi. That would put me in the second quadrant, between 0 and pi. Since it's negative, I've got pi sixth in the second quadrant. Pi sixth in the second quadrant is 5 pi sixth. It is pi minus pi sixth. In the second quadrant, I've got pi sixth. What is this angle? Well, it's got to add up to pi, so this angle has to be 5 pi sixth, because pi sixth and 5 pi sixth add up to pi. Now, guys, there's just a few problems on this section that are like that. If I'm looking at it, for example, I see that when I get to 33 through, actually through about 41, a lot of them are going to be that way, or if they've got a negative on them, they're going to be that way. I suspect that on this section, problems 31 through 48 are going to be the ones that, if you have problems, have your difficulty, it's going to be on those. Probably, not trying to make life easy on you, want you to work this stuff out, figure it. We probably can live with you if you understand everything through problem number 30. We're probably going to be in pretty good shape. Would like you, though, to try to work some of these. Okay, that's our lesson, on our 2 lessons, actually, on section 5.5. You guys work on this stuff. Guys, be safe. Do what they tell you. You guys, be safe. Don't get that stuff. Be talking to you later. And when I say that stuff, I want you to get this stuff. Don't get what's going around the U.S. right now.